Hello guys, in today's video we are going to see one more new topic which is orthogonal matrix. So orthogonal matrix is also very important topic. You might get 10 marks question for this. Like they'll ask you what is orthogonal matrix and an example sum. But for that example we have different models. Okay, one directly they'll give all the numbers in the matrix and they'll ask you to find the orthogonal. I mean whether the matrix is orthogonal or not. That is one type of model, and the other model is they'll not give you all the values in the matrix. They'll give few elements as numbers and few as alphabets like ABC, and they'll say that this particular matrix is orthogonal matrix, and they'll ask you how to find the values of ABC and what are the values of ABC. So you have to find the values of ABC. We will see both the models. Okay, in this video I'll explain you a normal sum, and in the next video I'll explain you the other type of model. Okay, first let's see what is orthogonal model. So whenever a square matrix, okay, whenever a square matrix is said to be orthogonal, means if it satisfies this condition, that means A into A transpose or A transpose into A is equal to I. I means what? Identity matrix. We have discussed this matrix in the introduction part. So if you don't know about that identity matrix, I recommend you to go watch in that video and then listen to this orthogonal matrix again. So you have to know the identity matrix first to check whether the condition. Identity matrix means what? All the diagonal elements should be 1 and the remaining elements should be 0. That is identity matrix. I have explained you in short. You can just go and watch that video for the example also. So this is orthogonal matrix. That means this condition should be satisfied. And this is note. Okay, these are like again theorems. You can't say exactly the theorems, but a type of statements which we can use for the problems. Okay, remember these 2 points. If AB are orthogonal matrices, then AB and BA are orthogonal matrices. Okay, inverse and transpose of orthogonal matrix is again orthogonal matrix. You have to remember these statements because yesterday we saw that the theorem results we have used in the problem solving, right? Similarly we will use this concept or note points in some other problems. So it is always better to remember these kind of note points and the conditions. Okay, whenever it's not about only this matrices chapter, I'm telling about every chapter and in any subject. If they specify you any particular type of conditions, then that conditions will be very much useful in any of the problems or any of the concept interrelated. So make sure that you don't miss all those points. Okay, now let's see how to solve the example. Okay, this example I have taken. See, in the exam you will, so in this example it's cos theta sin theta. I want to explain this model. They'll give you like this cos sin, and in this you have to solve this using the cos theta and sin theta, those formulas. Okay, so I'll explain this first, and then the other model is they'll give you A this way and they'll give you regular matrix like 1 2 3 using numbers. Okay, that is other type of model. We'll see all these 3 different models for this orthogonal matrix. Okay, now how to solve this? We know that orthogonal matrix means A into A transpose or A transpose into A. Nothing is there, it's multiplication, right? So dot equal to I. If we prove this, okay, if the result is this I, then particular matrix is said to be what? Orthogonal matrix. Now we can find A into A transpose or A transpose into A. Again see here we have properties in the transpose. I have already mentioned this. A into A transpose equal to A transpose into A. So we are using that here again. So that is why you have to remember all the properties and the conclusions of the theorems. Now first let's find A transpose. So what is A transpose? We have to write the columns, rows as columns or columns as rows. Now take first row, write it as a column now. Cos theta, sin theta. Next what? Second row, second column. Minus sin theta, second one is cos theta. Now what we have to do? A into A transpose. That means we have to multiply the 2 matrices. So first write A. Cos theta, sin theta, minus sin theta, cos theta. So you have to know the multiplication of matrices. I'll explain you in this sum only. If you know in prior, that's very easy. Then write A transpose cos theta minus sin theta and then cos theta. Okay. Now, how to multiply the matrices? If you take first element, what you should do? You should come for the first element. You should completely multiply the first row with the first column. Then this will be the value. Okay. What about this element then? Again first row, second column. Okay. That is how you have to multiply. Whatever the position you are finding, that particular column you have to choose and the row. Okay. Now first, what is the thing you have to write? I'll write it clearly for the first time. Cos theta into cos theta. You are finding this position, right? You have to, what is this position? First column. So you have to multiply this particular complete row with the first column only for this first position. Okay. If you are finding the first row, second element means it's second column. So you have to multiply this complete row with the second column. For the third. Okay. Likewise. Cos theta into cos theta, cos square theta. Okay. For the first time I'll write it clearly. Cos theta into cos theta. Plus you have to add, because we have one more element, right? Sin theta into sin theta, what? Sin theta into sin theta. Now for this position, that is second position. So you have to take the row again, second column. Cos theta into sin theta is what? Minus sin theta cos theta, or minus cos theta, so anything is fine. Plus sin theta into cos theta is what? Sin theta into cos theta. Yeah, you have to add the values. Okay. Now again for this position means you have to take this row, and this is first column, right? So you have to multiply with the first column. Minus sin theta into cos theta is what? Minus sin theta into cos theta, plus again minus sin theta into cos theta into minus sin theta into cos theta, plus cos theta into sin theta. Okay, this element with this. Now this position means again second row, second column, because it is in the second column. Minus sin theta into minus sin theta, both are minus. Next, plus next element is cos theta into cos theta into cos theta, right? Now let's solve this. What is cos theta into cos theta? Cos square theta, plus sin theta into sin theta is sin square theta. Again here minus sin theta cos theta is, we can't solve it further, you have to write the same way. Again sin theta cos theta, it's again same, sin theta cos theta. Alright. Now minus sin theta into cos theta is again minus sin theta cos theta, plus cos theta into sin theta is cos theta sin theta. You can't solve it further. So now again minus sin theta into minus sin theta, sin square theta. Minus into minus is plus, so we don't have to write again. Plus cos theta into cos theta, it's cos square theta. Okay. Now what will be the result? We all know that according to trigonometric formulas, what is cos square theta plus sin square theta? The value of cos square theta plus sin square theta is 1. So here minus sin theta cos theta plus sin theta cos theta. So it can be cancelled. Minus and plus, right? We can cancel off. 0. Same here also. Minus sin theta cos theta plus sin theta cos theta. Cancel. 0. Again here same formula. Sin square theta plus cos square theta is 1. So the resultant matrix is what? Identity matrix. That what is identity? Diagonal elements are 1s and the remaining elements are 0, which is equal to I. So hence our condition A into A transpose equal to I, which is orthogonal condition. It is satisfied, and hence this matrix is called as orthogonal matrix. Okay, this is how you have to find. And in the next videos I'll explain the model, two different models. Okay, I'll make separate videos for each model. Thank you.